Here are solutions for Math 111 per problem 5. We're given this function, f of x. Yeah, I guess I'll do it down here. Well, maybe I can do it up here. F of x equals x squared plus 4x plus 3. And in part A, it's saying express that in a different form. Express that so it looks like this. The way we can do that is by completing the square, in short. It's not a perfect square. X squared plus 4x plus 3. It's too bad. X squared plus 4x. If there's a certain number I could put here, I could make this part of it a perfect square. I think the number you'd need to put right here would be plus 4. But you can't just go adding 4. I mean, yeah, I could write plus 4 right here, but now I've changed the value of this function. But I can add 4 as long as I make sure I take away 4 later on. Right? Then I haven't added anything at all. Maybe I write them right next to each other so it's easier to see. But the advantage of putting in this plus 4 minus 4, even though it doesn't change the value of the function, is now right here I have a perfect square. Specifically, I have x plus 2 squared. So that's all of this stuff. So what's left over is minus 4 and plus 3, which nets out to minus 1. So for part A, express this function in this form. I've done it. A equals 1, B equals 2, C equals negative 1. All right. Sketch a graph of f of x by first sketching g of x. All right. Never too happy to sketch graphs online because they typically turn out pretty messy. I'll give it a shot. So I first want to graph just x squared. So when x equals 1, y equals 1. And when x equals 2, y equals 4. 1, 2, 3, 4. When x equals 0, y equals 0. When x equals negative 1, y equals 1. And when x equals negative 2, y equals negative 2 squared, which is 4. And so in green here, nope. If I'm really careful, I might be able to connect these dots decently. Good enough. So this right here is g of x. Whoa, g of x. But that's not what it wants. It wants me to graph f of x. So I can do that maybe in a different color. Let's write it over here. F of x, I figured out in part A, was x plus 2 squared minus 1. So this is going to shift to the left by 2. And this will shift down 1. So I can keep track of where all these points go. This point that used to be at 2, 4, left 2 brings me here, down 1 brings me here. This point that used to be at 1, 1, left 2, down 1. This point that was at 0, 0, left 2, down 1. I need some more numbers on my axis. This point that was at negative 1, positive 1, left 2, down 1. And finally this point that was at negative 2, positive 4, left 2, down 1. Be right in there somewhere. And so what I have, try my best, a graph of, bam, f of x. So part B, sketch this graph by keeping track of these points. Yeah, I guess I did all that. I even labeled the transformations here. On a separate axis, all right. So this is C over here, which I guess means this was B. On a separate axis, graph f of x with its domain restricted to negative 2 infinity. What that's saying is copy that thing I just made, except stop the domain right here. Stop the x values right here. So this half of the parabola is gone now. Just keep the rest of them. I got this point, and 1, 2, 3. This point right here. So if I'm just graphing the right hand side, if I've restricted the domain, I end up with something like this. Clear, I got all those points. So on a separate axis, graph this. 3 of the above 5 points should be on this restricted graph. Yep, they are. 1, 2, 3. All right, part D. By restricting the domain, my graph is now 1 to 1. Yeah, it is. It would pass the horizontal line test. So I can talk about its inverse. Sketch a graph of its inverse by plotting 3 points corresponding to the 3 that you have labeled on your restrict, blah, blah, blah. Okay, what I'm going to do now is say, I have this point right here, which is x equals -2, y equals -1. If -2, -1 is on my graph, then -1, -2 is on my inverse. If -1, 0 is on my graph, then 0, -1 is on my inverse. If 0, 3 is on my graph, then 3, 0 is on my inverse. In other words, I get a graph that looks something like this. So this is f of x restricted, and then this is f inverse of x. All right. You might see there's some symmetry going on here. That's always true. This is going to be symmetric across this diagonal line here whenever you're talking about inverses. And that's because we're basically switching the inputs and the outputs. We're changing all the y's and the x's. Check your answer to part D by finding f inverse of x algebraically. Okay, can do that. I knew that f of x was equal to, I'm going to use this form of it. I think that'll be a little bit easier. So to find its inverse, what I'm going to first do is change f of x into a y. And then I'm going to solve this equation for x. So add 1 to both sides. Take the square root of both sides. Normally, when you take the square root of both sides of an equation, you have to put in a plus or minus right here. However, we're not going to put in a plus or minus this one time, and it's because we restricted the domain. We kind of already got rid of all the minuses. We've gotten rid of this bottom half of this graph on the inverse by getting rid of the left-hand side of this original function. So I don't put plus or minus here, I just put plus. Anyways, then subtract 2 from both sides, and you get x is the square root of y plus 1 minus 2, which we could write in function notation as f inverse of x is equal to the square root of x plus 1 minus 2. And then lastly, to check my answer, I guess what I would do is I would say this right here is going to move me, well, how's it asking me to check my answer? Check your answer to part D by finding the inverse algebraically. I did that. Then noting how it is just the transformation of this guy. Okay, so maybe I'll draw another graph, although this is probably a little bit over the top. This right here is the graph of h of x equals the square root of x. I don't know that you have to draw this, but I'll do it just for illustration's sake. This is what the square root of x looks like. But I don't want the graph of the square root of x. I want this guy, which is the graph of the square root of x shifted left by 1 for this plus 1, and then shifted down by 2 for this -2. So what I do is I take all these points and move them left by 1, down by 2, left by 1, down by 2, left by 1, down by 2, and what I get is exactly f inverse of x. Bam. Maybe I'll even write, you don't need to draw this graph. But for me, it made it easier to illustrate what was going on here. But if you don't want to do it, you don't have to. Just note that we're shifting left 1 and down 2, which ends up right on this guy. I think that's about enough of that, so we'll say that's the end.